photosynthesis, and so what happens is light and CO2 come in, and so help me out here.
It starts with two water molecules that get split, and the 4 oxygen and the 4 hydrogen and the 2 oxygen get split. So then the 4 electrons get passed through photosystem 1, the what's it called?
The
Cytochrome C, and through photosystem 1, and the electrons help carry the hydrogens through.
And so the oxygen, when this splits, just diffuses through the membrane.
Can you show me the movement? Like, show me movement. Show me things moving.
Okay. Well, so the oxygen and the hydrogen split up like this. You want to help me out here?
They don't have to be perfect.
And so then these split up, and then the oxygen just diffuses through the membrane out there, and so
it hooks with this one to make O2.
And then the electrons
this is just a different stage.
Yeah, get pulled through. So it's just like that. These are the same things, but instead of just pulling it through like this, we
because they could break off.
Yeah, we attached 2 different versions of it. So like this is the first part, and
So
then
what's
this is the
even
second part.
what's the point of the electron transport chain? What are electrons doing in this? And in this? So what's the point of the electrons? What are they doing?
They're releasing energy
to do what?
To make ATP.
And so then as the electrons go through here, the hydrogen or the protons
have a higher
concentration gradient on this side. And so
how did they even get there? How did they get there?
They're being pumped.
Yeah.
From what?
They get pumped through
these protein
Where did they
channels.
get the energy to be pumped?
Through the electrons.
Ah, there we go. There
There
we go, Elizabeth. I knew if I asked enough questions.
And then the hydrogen gets pumped through the ATP synthase
and
while
it
turns.
rotates, and
It might not turn that well. This is an extra phosphate group that it gets attached onto, and it attaches maybe to make ATP. And then at the end you have the 4 electrons that helped it move through, 2 hydrogens and 2 NAD plus to make NADPH.
And where does that NADPH then go?
It goes to the cellular respiration.
These are 2 different systems. Where does the NADPH go after this? So what comes after the light reaction?
The Kelvin cycle.
There you go. And what are they eventually converted into? NADPH is
Glucose.
eventually, yeah, thank you. All right, so here we are at, yeah, let's have, okay.
Well, to explain the similarities first, we have the electron transport chain, which is on the membrane, and so basically the hydrogen ions or protons are getting pumped here into the thylakoid space and here into the inner membrane space to get a higher concentration on both sides, and then they have the protein channels, and then the ATP synthase is the same. We just decided to make 2 systems instead of creating one. And the whole idea of the electrons getting pumped through the protein channels is the same idea.
Okay, all right. So go ahead and start with
So this side of the respiration starts with NADH that goes through the complex, is that what they're called? Yeah. Complexes, maybe. And the hydrogen gets split off, so it makes NAD, and then like photosynthesis, the 4 electrons get pumped through each of the complexes, and the same thing happens with FADH2. It attaches on, and then the hydrogen gets split off, and it turns into FAD. And then when the hydrogen gets pumped through, so for the concentration gradients, it starts again with the hydrogen that gets pumped through, that starts as ADP, gets pumped through the ATP synthase as it turns. It gains an extra phosphate group, it turns into ATP. And at the end of it, you have the 4 electrons that helped it pump through, 4 hydrogens, 2 oxygen, which make 2 water molecules.
Cool. Anything else?